Welcome to Data Center Richness. I'm Rich Miller, and on today's show, we're going to be talking with the leadership team at Verrus, an all-star team of data center pioneers who are rethinking the data center for 2025 and beyond. That includes new approaches to some of the huge challenges the industry faces around power and design. I believe Verrus will be an important company to watch in the next few years. It plans to use software, AI, and deep wells of engineering experience to improve how data centers interact with compute workloads and the power grid. Their plan is to create grid interactive data centers that use energy storage and software to work more effectively with utilities, along with data center designs that optimize every watt at every point of the power chain. Verrus is backed by Alphabet spin-off Sidewalk Infrastructure Partners, and much of the Verrus leadership team helped create Google's hyperscale data centers. That includes my guests today, Nelson Abramson and Anand Ramesh, the CEO and CTO of Verrus, who will share about their experience at Google and their vision for the future of the industry. Their team also includes veterans of Twitter, Apple, and Meta, who collectively have deployed 13 gigawatts of data center capacity. If you're wondering what the future of data centers will look like, I think you'll enjoy today's conversation. Let's get started. Welcome to Data Center Richness. I'm Rich Miller, and I've spent 25 years telling the story of data centers, cloud computing, and AI infrastructure. In this podcast, I'm sharing conversations with the innovators building our digital future. Now, here's our show. On today's show, we're going to be talking with the leadership team at Verrus. I wanted to just start with asking Nelson and Anand to introduce themselves and tell you a little bit about their background and about Verrus. Nelson.
Sounds great. Well, I'm so excited to be here, and thank you, Rich, for the opportunity to come chat with you. Nelson Abramson, I'm CEO at Verrus. I've been in data centers for just about 25 years. I spent most of that time at Google, where I worked on just about every part of the technical stack that makes data centers work. So I've done dirt and site selection, I've done concrete and steel and construction, I've done server storage network systems, system software, application software, planning, logistics, and actual operations of the facilities themselves. I also spent some time running infrastructure at Twitter, and I got recruited to come over and be CEO at Verrus, and brought it out of stealth just about 18 months ago.
Anand, how about yourself?
Thanks again, Rich, for having us on. Really appreciate it. Really looking forward to the next hour plus of data center nerdery, if you will. So I'm Anand Ramesh. I'm CTO of Verrus. Like Nelson, spent a bunch of time at Google, roughly 14 years across 2 stints. I worked on, again, different aspects of Google's infrastructure stack there. Notably servers and storage, as well as data center design and construction, software product management, also Google Energy, where I did a 2-year stint, site reliability engineering, which helps manage services at Google, and also did a stint at EdgeConneX, which is a third-party data center provider, before coming to Verrus to help design and launch the product.
Obviously, you guys have a great deal of experience at Google and in other companies that have a long history in the data center sector, and thus are very familiar with how data centers have been built and what innovation has looked like for a long time. With that as background, tell me about how Verrus is different, how you thought about creating the company, and how you're approaching the challenges in the data center industry right now. Maybe Anand, do you want to start?
So we are backed by Sidewalk Infrastructure Partners, and when they first approached us about building this together, my first response was, well, third-party data center capacity tends to be commoditized. It's very cool that there is actually appetite for designing and building a better data center. I'm not really sure that anyone is in the market for that. Um, but honestly, our hope is the capacity angle, right? Because what customers care about is capacity at the right time in the right place, and that is what Verrus is uniquely positioned to deliver through very interesting and novel technology. But we are offering capacity in markets that we're pretty sure customers want to be in. That is our value proposition, first and foremost. Um, Secondly, it was the opportunity to work with folks that I had worked with for a while. So I've known Nelson pretty much from the day I started at Google, and I've worked with him on and off over the past 2 decades. And this was too good an opportunity to pass up to kind of do this again, get the band together, so to speak, again. So yeah, like those were our motivations, at least from my point of view, of sort of jumping in with both feet. Um, yeah, and we're incredibly excited about the future. That's it.
Uh, yeah, and in my mind, first and foremost, we're trying to build the kind of data center company offering the kind of products that we wished had existed when we were on the other side of the table. And I think when we came into this, I had sort of similar emotional journey to Anand, which is like, what's the approach here that's something other than just building another data center? And, from my mind, when I look around, what I see are data centers that are much bigger than they used to be. First data center I worked in was at the time a mind-boggling 1.3 megawatts of power, which today is like a rack and a half or 2 racks. So it's like it's incredible the journey that data centers have been on technologically and in every dimension. But what I see is fundamentally the same data center but bigger. And I think if you took a data center today and time traveled it back into the 90s, like it would look very familiar. And I think what's happened is we've experienced such rapid and incredible growth of demand and scale for what it is to be a data center that everybody's just been racing to keep up. And to our mind, it's like, well, once you start reaching these kinds of scale points, there's an opportunity to fundamentally reevaluate what a data center is. And rather than looking at it as a piece of industrial real estate that happens to consume power as a side effect of it existing, it's really fundamentally an energy asset that happens to need real estate because you got to put it somewhere. And that somewhere really matters. Like, I'm not suggesting the real estate part of it is not important, but you really have to think about it as an energy asset first. And once you make that mental leap, it opens up a whole bunch of other doors. You're like, well, what else can we do if we think about data centers as an integrated technology system, as an energy asset? And it opens a whole bunch of potential doors that lets us do something different while still delivering fundamentally the same product to customers, which is space, power, cooling, capacity for your servers, whether it's GPUs or compute and storage. But it delivering that product in a way that really meets the current moment. When we think about grid constraints, when we think about scale and scale constraints, and like, okay, hey, we want like 3 times the number of data centers ever built in the next 5 or 10 years. Like that is just that's an incredible amount of data centers we have to build. We got to do it different.
So in doing it differently, you mentioned meeting the moment. Power seems to be the story of the moment. You mentioned the constraints, lots of markets. It's hard to find power in the scale and timelines that folks would like. In thinking about Verrus and how you might approach that differently, tell us about what you guys are looking at. Where are the solutions here?
This is actually very timely, Rich, because we know you posted Tyler Norris on your podcast a couple of weeks ago, who
Right.
spoke about what demand flexibility can actually do towards alleviating some of the power shortages that are widespread in the industry today. We happen to concur very, very sort of studiously, I should say, that yes, this indeed is the opportunity to sort of unlocking significant amounts of capacity on the utility that's out there. So Nelson basically mentioned that, hey, we're looking at data centers being an energy asset. Uh, the sort of extension or the natural extension to that is that we don't envision data centers in the future being passive consumers of electricity as they have been in the past several decades. So usually the way things work is that a third-party data center provider or hyperscaler arrives in a utility area, and they ask for an interconnection, a substation gets built, and then they drop out. Um, the way that things are going to work, we believe, is going to be quite fundamentally different, which is that the utility interconnection is going to be accompanied by some level of flexibility that's being asked of this very significant consumer of load, specifically during peak hours. And those peak hours could vary between dozens of hours to hundreds of hours a year, where data centers may be asked to essentially appear to the utility as if they're dropping. So the trick in doing this is going to be in a manner where customer workload is actually not impacted. So it's one thing to go ask customers to go and shed workload. It's another thing to go to customers and say like, hey, we're able to actually deliver this without any net impact to your workload. And if there is additional flexibility that that customer workload can bring to the table, that's over and above what we can actually do. The way that we want to do this is fundamentally with energy storage. So we want to deploy long duration energy storage in our data center campuses. That will go a long way towards creating dispatchable resources, firm dispatchable resources for the utilities that basically unlocks the flexibility that's needed to deliver this interconnection capacity. That is our kind of fundamental approach, where we want to start with long duration energy storage as the key mechanism by which flexibility is offered, and then slowly walk our way with customer participation, if they so desire, to adding IT workload flexibility into that mix.
So Nelson, to build on that, energy storage systems are something that, haven't necessarily been as prominently featured in data center usage and cooperation with the grid to date so much, apart from a traditional UPS system. Normally the setup is you would go to a UPS and until you can start up some generators, and that's how you would run if the grid is out. But what has enabled you guys to think a little bit differently and approach this, the data center as an asset?
Yeah, I think a number of different changes have happened across a bunch of different industries, all that kind of have related and interconnected into data centers, and they've all kind of converged into the current moment. And so a big piece of it is just when you're talking about siting a 5 or 10 megawatt data center load, it's just a different level of consideration for the utility, for the transmission and delivery systems that they have, and for their generation portfolio. When you're talking about a gigawatt data center, that's no longer something that can just kind of tag along with an industrial park or even a commercial park. I mean, again, the early data centers I worked in were, behind a packing warehouse or a post office, right? And that's just that those days are gone. And so when you're talking about siting a gigawatt data center or multi-gigawatt data center, at that point, you're having the same kinds of conversations with utility that you have to have when you want to site a power plant, because it's the same kind of impact to the grid. And so the first is just data centers have gotten so big and so concentrated that we've had to think about them separately. I think we also should be thankful to electric cars for driving the price of lithium batteries down, and not just lithium battery technology in general, inverter technology. Like, the result of all this incredible global investment in production and design of electric vehicles, now you're like, oh, well, actually, we can take advantage of that technology from a cost perspective, but also from a complexity and sort of proof of work perspective. And we have these systems that didn't exist before. And I think the other is the evolving perspective of how reliable the grid actually is, and fundamental willingness to look at the needs for reliability and durability to outages in a holistic fashion, which is like, hey, there's a whole bunch of categories of failures. What is the best way of actually approaching these, as opposed to just this is the way we've always done it, or this is the way we did it in the last data center, so it has to be the way we do it in the next data center. Instead, it's like, let's look at this clear-eyed and through a what do we want to get out of it kind of perspective, taking into account all these other things that are happening, which are like fundamentally or a little bit orthogonal to data centers themselves.
So do you have any examples of what some of the newer different kind of things you could, think about in managing that?
In terms of like how our data centers take advantage of all the scale and the opportunities here and the changes in the market, I think there's a few that are probably the most interesting to you and to your audience. I think one is that our data centers take a novel approach to the design and implementation of the electrical infrastructure to be incredibly more efficient in terms of how many racks you can get on the same number of kilowatts. And so you can get approximately 30% more racks into the same underlying megawatts with a Verrus data center that you can get from anyone else. Another is our approach to how that facility is delivered allows you to use a wide variety of deployment vehicles. One of the things that I faced in my previous role was always a challenge for knowing what kind of racks and servers and form factors you were going to deploy. The only thing I could ever guarantee was whatever we assumed was wrong. And we would regret whatever we had assumed in approximately 6 months and sometimes 6 weeks. And, that was even before the incredible advancement and replacement curve that we're seeing on GPUs. And so, core element of what we're building is flexibility to, hey, do you want a lot of water cooling? Do you want a lot of air cooling? Did you change your mind and you want to go back to water cooling? Do you have dense racks or not so dense racks? The ability to have that flexibility is a key element to the kind of data center that we're delivering. And then the final piece is our special relationship with the utilities, because we're able to bring not just the promise of flexibility or small amount of sort of nominal flexibility. We can actually offer firm flexibility through our use of on-site behind the meter resources that don't have the kinds of run restrictions that you'd have on a diesel. Utilities are willing to work with us in a unique way and let us help them to unlock capacity, similar to what Tyler was talking about in his paper for like, hey,
Right.
there are really two grids. There's the grid that happens, 8,500 hours a year, which is there's plenty of room. There's plenty of room in the generation portfolio. There's plenty of room on the T&D side. And then there's the grid that happens a few hundred hours a year when it's a super hot day. Everybody comes home and cranks their air conditioner and the sky is a little cloudy, so solar's not doing great, and it happens to not be windy, so wind's not doing great. When you have those days, those hours, those days, it's a very different grid. And so thinking about these things as different planning problems and different operation technology problems, again, sort of it opens your mind, opens your opportunity space in a way that isn't when you have to think about just this one operating point that has really very little flexibility in it.
Right. And just to quickly summarize, for those who haven't seen our podcast with Tyler Norris, the idea is, Tyler and his colleagues at Duke did research effectively showing that if data centers could be flexible for a certain amount of hours a year, it changed the way that the utilities can think about of their peak demand. That if there could be more flexibility and cooperation there, then the data center load requests could be thought of slightly differently. Anand, is that about right?
Yeah, that's basically exactly right. So the I believe the rough order of magnitude that was quoted was hundreds of gigawatts or 100 gigawatts or thereabouts. That's the entire idea behind the premise. To also add on to what Nelson said, I think the value propositions around load flexibility as well as design flexibility, etc., are sort of near and dear to our hearts. But I think I want to sort of also underscore that customers need not modify their workloads or their deployment patterns in any way. A Verrus data center should look and feel like a traditional facility that they deploy into without them needing to really modify anything about their deployment patterns or their deployment methodologies.
Yeah, well, that was going to be one of my questions. Is it sounds like most of what you're talking about is things that will happen on the back end. And one of the things I'm interested in is the utility relationships, because that's one of the things that over the years, a lot of data center companies have not been eager to think of themselves as power companies or being in the energy business. Um, what does that relationship look like, or what should it look like now? And how are you guys thinking about that?
Yeah, I mean, that's a key part of how we've built Verrus and how we have changed our approach from business as usual, which is engaging utilities really as strategic partners. And that requires us to operate a little bit differently and think and act a little bit differently in terms of how we engage with the utilities. But I think what we've found is utilities overall are hungry for a different kind of approach. I think nobody knows better than the largest utilities how challenging it is to just continually connect these data centers that operate as black boxes and have and offer the grid really no upside other than load. And as you were mentioning, Rich, in what the Tyler's paper showed, even just small amounts of marginal flexibility really unlock things in a similar way. I think the planning metric is something like each 9 you add is like double the cost. It's something similar where, like, for utility, the farther out you go in the curve, the harder it is for them to meet the demand and like the most extreme opportunities. And so being able to offer those kinds of opportunities those kind of options, kind of firm options to a utility that allow them to play their planning game in a more effective way. We found in general utilities are very interested in this approach and are really looking for something different and the thing that we're bringing. I think this is this is a new space. I think there's been at this scale for these kinds of flexibility needs, it is a fundamentally new space, and so we're excited to be working with some of the most thoughtful and forward-thinking utilities in the United States on what should this look like, how should we structure it, how is this actually going to work in a way that delivers enough value for the utility to unlock this stranded capacity and at the same time offer the right kind of grid interconnect that a data center can still operate well. Because in the end, a data center is in the business of providing capacity for compute storage GPUs. And so, this has always been one of the key blockers is like, how do we strike this balance between these needs in a way that everybody gets enough of what they need that it works well?
So, Anand, let me then ask, what are the components that you can work with in crafting a different relationship with the utilities? Is it individual contracts with data centers? Is it, tariffs? What are the moving pieces here where you guys can approach things a little bit differently?
It's been a process of discovery for us, right? So utilities are incredibly complicated organizations and they do incredibly complicated things. It's not an overstatement to say that the electrical grid is probably the most stunning human achievement of the last 100 years. It's basically underscored every single boost in productivity that we can think of, from lighting to air conditioning to computers. So we understand and appreciate that these are incredibly sort of complicated systems which require very careful kind of care and feeding. So to answer your question specifically, there is no one-size-fits-all approach, right? So in the sense that every utility has very specific needs, and it isn't even a utility by utility specific conversation. Oftentimes it's a region by region conversation within that particular sort of utility area. And the kinds of offerings that we come up with are oftentimes in direct conversations with them after they do modeling and studying on their end. So it's very much a two-way conversation, which takes time to kind of build and evolve. The hope is that we can actually begin standardizing some of these offerings, which do have sort of certain level of commonality, say across 80% of deployment scenarios. And we have no intention of kind of keeping that sort of thing proprietary, right? Like, I think we believe pretty strongly that it's going to benefit the whole industry if there's a certain set of offerings that can be essentially be made public, where data center companies may be asked to kind of participate in that set of offerings. So yeah, like it's not a satisfying answer necessarily to your question, but it is a very utility by utility and region by region conversation. And that's kind of why it's painstaking. But I think it's worth laying the road, because once the road is built, then driving on it then becomes a choice, right, for different data center companies.
Yeah, it seems like there's a couple of other folks thinking about this. There's the EPRI has the DC Flex program, and it seems like there's a lot of thinking going on in this area. Nelson, I wanted to come back to design. One of the things that you mentioned that you're thinking about power design a little bit differently. There's been a lot of discussion of, because of the density and that maybe folks have to think about distribution differently. Is that part of what you're looking at, or from the design perspective, what are the things that have to change to meet the kind of workloads that we're seeing and customers are trying to manage for?
I mean, I think the short answer is definitely yes. In terms of, are we looking at it and does it need to change? I actually think Anand is much better at describing it than I am. And so I would punt to Anand to answer your question.
Well, I hope your eyes don't start glazing over as I sort of launch into raptures about electrical design and mechanical plant design. But I'll start with like a very sort of simple set of observations, right? So very traditionally, there's an interconnect request that gets made for, let's say, X 100 megawatts. Let's say for the sake of argument, it's for 200 megawatts. Approximately 125 megawatts gets allocated to IT, 75 megawatts gets allocated to cooling and other overhead, right? Like, you can work out the POE math. And then out of that 125 megawatts that's allocated to IT, it ends up getting built over a course of 3 or 4 or 5 years. And when the campus is fully operational, the power meter will tend to read somewhere between like 75 and 90 megawatts most of the time of IT. Sorry, we are so serious about efficiency that the lighting timers are set to a very annoying 10 minutes. The upshot is that an interconnection request is made for 200 megawatts, and the actual use that's seen by that substation is of the order of 150 megawatts. You almost never end up using the full power capacity that the substation has been designed for. So in today's context, given that capacity is reserved, we think that's a pretty significant opportunity, which is independent of all the flexibility value propositions that Verrus wants to bring to the table. So we are coming up with what we think is a new metric called overall utilization of energy. We think that the ratio of power that's basically supplied to the campus to what's being used by IT is something that customers should pay a lot of attention to, right? So that's from the utility context. And then a customer who leases from us, let's say they lease 125 megawatts from us, should get to use the entire 125 megawatts, as opposed to having the utilization sit at 75 or 80 megawatts. So that metric we think is going to be really interesting and relevant moving forward as we take advantage of all the power that's delivered to our campuses. So we do this in 2 ways. The first way is through electrical distribution. So the cheapest data center is the one that you never have to build, right? So if you can deploy additional capacity in our buildings without any negative electrical effects, by simply taking advantage of utilizations of data centers that tend to be significantly lower than 100%, we think that's a win for the industry. The second is obviously by optimizing mechanical plant design so that we are allocating as little of the power as possible to cooling and other overheads, which again is like a very traditional kind of a PE optimization play, right? So the way that we do this is again by electrical design where we're trying to pool electrical capacity at higher and higher levels. So more of that capacity is available for IT anywhere on the data center floor. So that in a nutshell is kind of how we go about our design and how we believe our data centers are going to be a better value proposition for not only for the utilities, but also for the customers, because they need to buy lesser Verrus capacity to essentially get the same amount of workload that's deployed.
Yeah,
And in terms of the opportunity there is that it seems to me that there's hardware, design, instrumentation, and software. Are those all pieces of the puzzle, or is there any one aspect of the pie that you guys think you can focus on in improving your results there?
So it's really all of the above, in all honesty. So the one thing that I want to be careful and again stressing is that uh, this is a complicated integration problem. So we have different layers of infrastructure that we're deploying in a various data center. And control systems, for example, is something that we take very, very seriously. Given the amount of energy storage that we're deploying, as well as optional backup, very traditional optional backup generator capacity, you need to find ways of managing these assets on your distribution system in a way that does not actually compromise stability and does not compromise availability of the data center as a whole. These are very solvable problems, but we are taking learnings in different fields and applying them to the data center field. So yes, there is a certain level of discovery, but it's not like we are coming up with new control theory, right? So that's how I would describe it. Similarly, on the flexibility angle, where we want to future-proof customers, we want to ensure that mechanical plant designs can tolerate a variety of interface conditions. So, for example, air-cooled workloads want a certain type of an interface condition to the data center, and liquid-cooled workloads may want a slightly different interface condition. And we want to design in the hooks for allowing customers the most amount of flexibility in terms of deploying one workload versus another.
Nelson, I'll come back to you with the business element of the opportunity, which is one of the reasons there's been a lot of interest in the Tyler Norris paper and in flexibility, is the idea that maybe this enables capacity and time to power in ways that hasn't been possible before. Well, what do you see as the possibilities as you talk to the utility industry?
I'll touch on both the sort of customer facing value as well as the utility value. I mean, on the customer value, my CEO version of what Anand said is you buy 3 data centers from Verrus and you get the 4th for free. I think it's hard to overstate the potential impact of that kind of improvement in TCO for delivering the data center, particularly in a world where, we have pretty much every cloud service provider CEO getting up and saying on stage, or on an earnings call, like our primary problem is building data centers fast enough. So like pulling a data center, like making it so you have to build that data center is both, I think, a huge win from a sustainability, from a climate, from an impact perspective, but also just straight from a business perspective of like, that's just a building you didn't have to spend. On the utility side, we are definitely seeing an opportunity, both from a time and access perspective, for like utilities just can give you a different answer when what you're asking for is much more of a configurable, manageable planning object rather than this black box, all or nothing answer that provides no great services. The moment we bring in the grid interactivity, the grid services element of it, it can and does fundamentally change the kinds of answers that we get from utilities, both from a cost, complexity, and timing perspective. But also in terms of the broader impact for all this load growth and all this data center growth, in particular to ratepayers, one of the best ways to stabilize rates for utilities, for utility ratepayers, is to allow the utility to deliver more power on the same grid. And so the more we can drive up the utilization of the grid on the, like, as I was saying before, it's like kind of 2 grids. There's the grid for 8,500 hours a year and the grid for 260 hours a year. The more we can drive up the utility for 8,500 hours a year without driving up the grid for the 260 hours, what that ends up meaning is the utility is able to spread their fixed costs over a larger and larger pool of power, which then stabilizes the rates for everybody else. And so it really addresses, I think, one of the key fears about data centers is like the potential cost shifting. Like, no, actually we can go the other way. We're going to shift costs in to the data center space simply by structuring that interface in a different way.
Let me back out just a little bit, take a slightly wider view in terms of business models where you guys kind of fit there. There's a lot of different ways in which folks nowadays are approaching data centers in terms of powered land, the developer. Some people just will lease all their space. Talk to me about the way that Verrus is approaching the market, what you're building, and what that looks like.
We are a full stack developer, and so we have sites with power, and we'll be building data centers on those sites to lease to customers. I think what we see as an opportunity to pull all these things together and deliver a competitive product out of the gate. Just to reinforce something that Anand had said earlier, although there is a whole bunch of opportunities for customers to take advantage of our unique design and value propositions, the entry point does not require any customer side changes. And that includes our ability to be market competitive. And so customer can start with a Verrus data center just the same way they've always used data centers, roll their racks in and get data center capacity. It allows them to dip their toe into the water and see the direction that the industry is going to go without having to take any of the change or the risk on themselves.
In terms of thinking about how you guys come out of the gate, obviously developing campuses at that scale is a capital intensive business. How are you thinking about how much to build, when?
I think there's a couple of elements there. We're looking to build data centers in the markets that matter. And so I think the long-term direction of this is going where data centers want to be, rather than just happening to find a substation somewhere that has capacity. And so we're looking at the major markets where all the customers want to be. The second is standing up a team. As you're implying, building data centers is not a business you want to cut your teeth on the first time at scale. This requires a team of experts, which we've assembled from the best hyperscalers and from the top 3 PDCs. Because to do this, the only way to know how to do this, the only way to build at scale is to have already built at scale. It's just fundamentally different to build a gigawatt campus than it is to retrofit a Heckinger's, which is one of the first data centers I worked in. Which, hey, it met that moment, but I wouldn't want to do that now. And so building the right team is critical. And the last element is, we're part of the Sidewalk Infrastructure Partners family. Their LPs are some of the largest infrastructure investors in the world. They're excited to be on this journey with us. And that's a key piece of this, because to build this is incredibly challenging in every dimension. One of those is you got to be able to deploy the capital to actually make the project work.
Anand, let me ask you about just the moment that we're in. We've talked about there's a lot of big challenges. You guys are looking at this as a big opportunity. It seems like an exciting way to approach the market. What's your take about what's possible here?
Without sort of injecting too much hyperbole into the conversation, I do fundamentally believe that data centers are going to change in a very fundamental way, right? So the way that data centers interact with utility grids and communities and with their own customers is going to look very different 2, 3, 4, 5 years from now. It is not going to be business as usual. But that being said, we also understand our customers are placing a tremendous amount of faith by deploying workloads into our facilities. So how do you sort of ensure that what you deliver can support their mission critical and revenue critical workloads that they choose to deploy with us? And the only way to do that is to rigorous engineering significant amounts of simulation and testing, which we can try and be as transparent to the customers with. So specifically, what do I mean by that? Like I said, there is technical complexity in what we're trying to do. But one of the ways that we want to kind of bring the customer base, the utility stakeholders, and the industry along is by working with credible third parties such as the National Renewable Energy Labs, for example, where we can kind of demonstrate at scale how our system actually reacts in a dynamic fashion, right? Like what are the transient effects that we're seeing, how are we mitigating them, and so on and so forth. So that's something that we want to be like very intentional about. We also have a pre-production environment at our facilities. You don't generally hear of a lot of third-party developers building test facilities for themselves. But again, one of the key sort of things that we want to do at our pre-production environment is by reducing integration risk. So what we don't want to do is to go to facility commissioning and then flip the switch on and sort of cross our fingers and hope that things work, right? So we want to kind of do a lot of that troubleshooting and debugging before the fact, where we have production intent infrastructure that's deployed, which is talking to our control systems and our software monitoring systems. That's the opportunity in front of us. We take it very seriously. We do acknowledge that, designs, et cetera, are going to evolve. And the way that we are trying to make that as painless as possible is, number one, by ensuring that customers don't have to change their workloads or their deployment patterns. And number two, by being as transparent and intentional as we can with this development process that we're on, and sharing the results with the community at large.
And just to add on to what Anand said, as an example, like we just co-published a technical report with NREL demonstrating what we did and how it worked, and that the Verrus design delivers the utility-facing value, the grid interactivity that we're promising at scale.
And obviously, we can share a link to some information on your website about the work with NREL. Nelson, you talked a little bit about the designs that might come into the data center. As we see very dense and advanced workloads, I think that we're seeing with AI hardware, is the modeling getting better to be able to work with customers as they're coming in. There's a lot of discussion of AI factories and digital twins as an opportunity to make it much easier to build a data center ahead of time and to reduce the amount of surprises when you actually try to commission something. What's the opportunity there?
As much as we're building data centers to house GPUs and AI for other people, it's also like a fascinating application of AI and AI related kinds of thinking to do improved modeling on the data centers themselves. I think, as with many applications of AI, we're figuring it out as we go. It's all new spaces, but it is a piece of what we're looking at, which is, hey, one of the things that makes data centers so frankly, so cool and exciting and interesting for me is just this interface between digital and analog technologies, where some of it is digital, you can model it, it follows sort of code logic, and some of it is, well, these are like physical things that sometimes move, and they do weird things that the manual says they shouldn't do. And really the only way to find that out is to like test it, and not just test it once, but test it a whole bunch of times. And sometimes the implications are actually quite subtle. And so I think there's a big opportunity here for being able to use an LLM-like approach. How can we build a better digital twin for this data center and, test it 10,000 times in all these different ways, and really identify some of these sort of subtler combined moments that might otherwise not jump out to a human observer, but could very well jump out to a sort of digital twin analysis mode.
Nelson, one of the things about Verrus and the way you guys are thinking about the data center development that are important for our audience to know as they think about how this industry changes going forward?
What we're building is the place where data centers will be in the next 5 to 10 years. And when I think about that, I think of combining a whole bunch of elements that we've sort of touched on as we went through this conversation, but maybe it's useful to sort of tie them together. I think a key piece is the right team that has the experience to really be able to look at this. And it's not just the data center technology, but it requires looking at the core data center technology. It requires looking at sort of software and control systems and operations. It requires understanding construction and supply chain. It requires energy. Like all of these different pieces have to have the right team built around them. Assembling that team, having the right people, having the right approach, and knowing how to make the right kinds of trade-offs, because everything is about trade-offs. That's the first and most important piece. Like the second being approaching utilities fundamentally differently, right? Like offering not a abstract promise, but like, this is how we can do things differently. This is the kinds of things that we can do. And this is how we can work together to understand how it's going to change the grid for the utilities and meet the moment for them so that we can work together and unlock capacities. Otherwise, just going to sit stranded. And then the third is the advanced design and implementation that we're talking about, whether it's on the energy side, on the power distribution side, on cooling, on how we deliver that capacity onto the floor, and how we work with the customers who are interested in seeing the market move forward and looking to do the next new thing. And I think we all feel like the thing are not where they want them to be. Where should it go? And so pulling all these things together lets us build that data center of the future and chart that course that we're excited to do, and we're excited to get there with the rest of the industry too.
Anand, any final thoughts?
I think that was a very, very elegant summary by Nelson. And, this industry is sort of at a turning point right now in terms of how it's viewed by utilities, how it's viewed by communities, and how it's viewed by the customers themselves. And I think there's really, at the risk of a little bit of hyperbole, a generational opportunity to fundamentally change how we think about some of these interactions and these problems, not only in a purely technical sense, but also in a commercial sense, like we've discussed over the last hour. So very exciting times for the industry, for sure.
For both of you, thank you so much for taking time. This has been a fascinating discussion about where we're at and where the industry might be going. If people are interested in learning more about Verrus and what you guys are doing, Nelson, where can they go for more?
Well, thank you for the opportunity, Rich. It's been a great conversation. I've been, long time reader. So it's great to be able to chat live with you. I think the easiest and most direct place is either finding us on LinkedIn or verrusdata.com, which is our website, and all of our core publications are there.
Thanks to Nelson and Anand for sharing their vision for Verrus. And I want to thank you for listening. If you enjoyed today's show, please take a moment to give it a like or a review. And be sure to subscribe to our channel for more Data Center Richness.